Hey everyone, welcome back to the channel Code with AKJ. Today is day 6 of solving LeetCode 75 challenge. So today's question is reverse words in a string. So the question says here given an input string S, reverse the order of the words. A word is defined as a sequence of non-space characters. The words in S will be separated by at least one space. So return a string of the words in reverse order concatenated by a single space. Note that S may contain leading or trailing spaces or multiple spaces between two words. The returned string should only have a single space separating the words. Do not include any extra spaces. So in today's video, we'll be solving a really interesting string manipulation problem, that is reverse words in a string. So we'll start with a brute force approach and then move towards an optimal solution. So let's dive right in. So the problem is simple. You are given a string S and you need to reverse the order of the words. The words are separated by spaces, but there might be multiple spaces between them or even leading and trailing spaces. So the goal here is to return the reversed words with only one space between them and no leading or trailing spaces. So given example here, string S, the sky is blue. Here, as you can observe, there's only a single space between these words and there are no leading or trailing spaces here. But when we come to the second example, here we can observe that there are leading and trailing spaces and we need to remove these spaces and reverse these words finally, and we need to return that particular string here. And when we come to the third example, here we can observe there are multiple spaces present between these two words. So we need to remove these multiple spaces and insert a single space between these two words. So here the brute force approach involves splitting the string into words. So we can loop through this particular string and identify words by detecting spaces and reversing the order of the words. That is, once we have the words in an array or vector, we can reverse that vector. And finally, we need to join those words with a single space between them and remove any leading or trailing spaces. So let's try to analyze this initial thought or the brute force approach here. So here I have written these three strings and we need to reverse this string by reversing the words in it. So after reversing, the answer would be blue is sky the, and for the second string the answer would be world and hello, and for third example answer would be example good a. We need to make sure that there should be no trailing or leading zeros and there should be a single space between words. So in our brute force, the initial step would be to split this string into words, removing all those extra spaces in between them and storing these words in a vector. So here we'll initially split this particular string into words where each word would be stored in a vector in this way. And our second step would be to reverse this vector, which will give us blue is sky the, and finally we'll join these vector values by adding a single space between them. That would be blue is sky the. So in this way, splitting the given string by removing all those trailing and leading spaces in between them and storing it in vector and reversing that particular vector and again taking these words and converting them into a string by adding a single space in between them. So since this brute force approach involves splitting the string, which takes O of n time, where n is the length of the string, reversing the array of words takes O of k times, where k is the number of words inside our string. So the overall time complexity of this approach would be O of n, and space complexity would be O of n, as we are using external data structure vector here. So let's move on to the code. So this is a code for the brute force approach we have discussed, where we have taken the vector of string which stores all the given words. We'll use the string stream function which is present in C++ STL, which will help us extract all those words inside our string, and we'll finally store them inside our vector. And our second step here would be to reverse the vector of words, and our third step would be to join those words into a single string, inserting single space between those words. So we'll run a for loop inside our vector of words, and we'll add the words inside our result vector, and until or unless it reaches end of the string, we'll add a single space between those words. And finally, we'll return the result string, which will store our expected output. So let's run this code. So okay, so let's submit. As you can see, it got successfully accepted. So here there's a follow-up question where if the string data type is mutable in your language, so can you solve it in place with O of 1 extra space? So there's a follow-up question where they have asked us to solve this particular problem in O of 1 time complexity to not use any kind of external data structure, as we have used vector of string in our brute force approach. So now let's try to improve this particular brute force approach. So the key observation here is that we can perform the reversal in place without using external space for storing words. The plan here for the optimal approach would be, first we need to remove all those leading and trailing or extra spaces between words. Second step would be to reverse the entire string, which gives us the words in reverse order, but the letters within each words are reversed. And finally, we'll reverse each word individually. This will correct the letters within the words. So for example, string hello world, our first step would be to remove all those trailing and leading spaces and multiple spaces between these two words. And second step here would be to reverse entire string, which gives us D L R O W O L L E H. And finally, our third step would be to reverse each particular word. So reversing each word gives us world and hello. So in this way, using these three steps, we'll get our expected output, and we have reversed this particular string in place without using any external data structure. Hence, our space complexity gets optimized to O of 1 from O of n. So in this way, we have optimized our space complexity, making it more efficient comparing to our brute force approach. So let's move on to the code, and then we'll try run with our example. So this is a code for the optimal approach we have discussed. So initially our step here would be to trim all the spaces, which is leading, trailing, and the multiple spaces between them. Here I have taken the help of a new function, which is trim spaces. We'll pass the string s here. So the function trim spaces goes like this. We'll take two pointers left and right, with left starts from index 0 and right starts from end of the string. So we'll try to remove leading spaces by moving left pointer. So until or unless it reaches to a non-space character, we'll move that left pointer. We'll remove trailing spaces by moving our right pointer backward until or unless it reaches to a non-space character. So in this way, our left and right pointer will point to a non-space character, and from here we can remove multiple spaces between these words. So our final step here would be to reduce these multiple spaces between words, as we have achieved removing both leading and trailing spaces using two while loops. So while removing multiple spaces between words, we'll take a string result and we'll use these two pointers left and right. So until or unless these two pointers becomes equal, we'll move our left pointer until or unless we'll find a space character. Once we find a space character, we'll stop our left pointer and we'll add all those non-space characters into our result string. If our result value has something in it and the result last character is not a non-space character, we'll add a single space in between them, and finally we'll move our left pointer. So in this way, with the help of our left pointer, we'll move until or unless we reach a space character. We'll add these all characters into a result variable, and finally we'll check whether the result variable has some characters in it or not. So if it has a character, we'll add a single space between them, and again we'll move our left pointer for the next word processing. So in this way, Using this while loop, we'll remove all those multiple spaces by adding a single space between these two words. And finally, we'll copy our result variable into our string. So since we are sending this string as a reference, we'll copy all those result string into our initial string. So here our step 1 would be completed, which is trimming all the spaces. And again, step 2 would be here to reverse the entire string. And finally, our third step here would be to reverse each particular word. So this can be achieved using a single for loop. We'll take a pointer start and we'll take a pointer end which starts from 0 till the size of the string. And if the particular end character reaches a empty character, we'll reverse the whole word starting from the beginning of string to that point of start. And finally, we'll replace our start pointer to the next word processing. So in this way, this for loop will reverse each particular word. So finally, after reversing each word inside our string, we'll get our expected output and we'll return that particular string from the main function. So let's run this code. It's working, so let's submit. As you can see, this works fine. So here the time complexity is O of n, where n is the length of the string, and whereas space complexity, the in place reversal gives us O of 1 space complexity, as we are not using any extra space except for a few variables. So let's try to dry run with a simple example. So let's take the sky is blue. So let's take this example string, the sky is blue. Since there are no leading and trailing, our second step here would be to remove the multiple spaces. Since we can see there are two spaces here, after removing these two spaces, our string would be something like this, which is the sky is blue with a single space in between these words. And here our second step would be to reverse the entire string. So after reversing this entire string, the string would look like this. So in this way, we'll get our reversed string. And now our third step would be to reverse each word inside our string using our reverse function. So here reversing each word gives us blue is sky the. So how this particular reversing each word works is we take a start pointer which is initially 0 and we'll run a loop with index end starts from 0 till the size of the string. So here until or unless this particular end character reaches a space. So if suppose the end character is here, we'll take this whole characters inside a temp variable. We'll take this whole string, reverse this word using reverse function, which is already present in C++ STL. And in this way, until or unless it reaches the end of the string size, we'll reverse each and every word inside our string. So in this way, we'll get our expected output by using in place reversal. In this way, we have optimized our space complexity from O of n to O of 1. So this was a small dry run of this particular string, the sky is blue. So to summarize, we explored two approaches to solve the reverse words in a string problem. The brute force method was easy to understand, but we optimized it to reduce space usage by reversing the string in place. So if you found this explanation helpful, please give it a thumbs up, share and subscribe to the channel for more coding solutions. So thank you for watching and I'll see you in the next one.